So Erin is saving money to buy a new toy. She has $12 in her account. She gets an allowance of $4 and plans to save $3 in her account. So the first term, the first week, she has 15. The second week, she has 18. What am I adding each time? So can you guys fill out that table? Add 3 each time, add 3 each time. These are my fabulous notes. Okay. So what are the numbers in the table? Go ahead. 15, 18, 21, 24, 27, 30, and 33. All right, Sebastian, move over to where Tyler usually sits now. Thank you. All right. So question B we'll come back to. Question C says, what's wrong with the graph of the sequence? What's the matter with that graph? It has a line through it. No line. Because the input numbers are whole numbers. And it says right here that this is a discrete linear function. A discrete function. Discrete means you leave points. Leave them as ordered pairs. Leave them as points. So we have to write the recursive definition, which is what we did yesterday. The recursive definition. So remember, to write the recursive definition, we always need the first term. What's happening first? I'm going to put a little note that says, don't forget, first term. So what's the first term? It's 15. A to the 1 is 15, okay? What are we doing each time? Okay, so I think we have all the information we need. So any term, like the nth term, equals the term right before that, which is a to the n minus 1 plus 3. This is the recursive definition. Dang it, sorry about that. I don't know why this is a little weird today. This is the recursive definition. Okay, you have to have both the first term and the equation. Okay, it says Evan proposes the following explicit formula. That's different. An explicit formula is different than a recursive formula. He says that this is the explicit formula, and this is the same thing as using this. It's going to give us the same results in the table. Well, we need to check it first. So let's check that formula. Let's let n equal 3. So if I use Evan's formula, I have a to the 3 equals 3 times 3 plus 15. But 3 times 3 is, and 9 plus 15 is 24. Compare that to week 3 in our table. Are those the same? Does 24 equal 21? No. So this explicit formula is incorrect. So they just wrote it down wrong. We're going to talk about how to write an explicit formula. So the important thing about an arithmetic sequence is every single time you are adding or subtracting the same amount from one term to the next. That's what you're doing. You're adding or subtracting. So if I were to look at this formula right here, this says, hey, my first term is -3. Let's figure out what the second term is. Well, that means I replace the I with the number 2. Well, 2 minus 1 is what? 1. So that means take the term before that, which is this, and add 6 to it, which equals 3. And the third one says, hey, take the term that came before that and add 6 to that, which is 9. And the fourth term is the value of the term before that. And we're going to add 6, which is 15. I know that manipulating the equation is hard. So I want you to think about when we learned about slope. If you knew the starting value, like if you knew the y-intercept or the initial value, right? If the first term was -3 and you knew what's happening every time, like what your slope is, weren't you able to figure out what numbers you should go to next when we did a table? Yeah, you did. You just add that. So -3 plus 6 is 3. 3 plus 6 is 9. 9 plus 6 is 15. So think of this as slope and don't get all caught up on the formula because I think the formulas are challenging. However, you do know how to manipulate those. Okay? All you're doing is taking the variables and replacing them with the term number. If you want the third term, you replace the I with a 3, and you replace the I minus 1 with a 2. 3 minus 1 is 2. Okay? All right. So arithmetic sequences, you still need that? All right. An arithmetic sequence is easy to spot because it has what's called a common difference. The common difference is represented with the lowercase, like cursive script D. And that's the same thing as what I said before. You add or subtract the same amount each time. If the sequence does not have a common difference, then it's not arithmetic. It's a different type of sequence. And there are multiple types of sequences. So if it's not, like if you can't add the same number or subtract the same number each time to get the next term, then it's not an arithmetic sequence. So let's see what's happening in example A. To go from 5 to 9, what did I do? Go ahead, Jacob.
Add 4.
And to go from 9 to 13, what did I do? Go ahead.
4.
Add 4. So to go from 21 to 25, what did I do?
Add 4.
So I'm doing the same thing each time. Do you guys see that? So the common difference is 4, and the missing sequence, the missing term in our sequence is what?
17.
Yeah, good job. So this is a good one. This is an arithmetic sequence. It's perfect. Let's look at example B. Let's see. The first time I add 5, but the second time I have to add 10, and then the third time I have to add 20. Am I adding or subtracting the same amount each time? You are correct, but that's not what I'm asking. That's a different type of sequence. So am I adding or subtracting the same amount? So this is not an arithmetic sequence. Pardon me? The answer would be 80, but we're not going to fill in the answer because it's not arithmetic. This is actually called a geometric sequence. We'll learn that semester 2. Okay, let's look at example C. What am I doing here? Subtracting 3. Every single time, correct? So Jacob, what's the missing term? What's 1 minus 3?
1 minus 3.
Mm-hmm.
-1.
-2. Close. That's awesome. So that means that my common difference is -3. This one is also good. What about example D? What do you think, Parker? It's what? Yeah, how come? Yeah, I'm not adding or subtracting the same amount each time. What's happening here? What are we doing to these terms each time? Dividing by 4. Up here, we were multiplying by 2, right? Both of these are called geometric. You don't have to write that down, but I just want you to know. We're going to do that later on in the year. Those are geometric sequences. They don't have a common difference. Okay. So every single time we add or subtract the same amount, that makes it arithmetic. So tell me what I'm adding each time to this sequence. Plus 10. So I started with a 4, I added 10, I got a 14. I added 10 more, I got a 24, right? So this says, hey, what is the fourth term? Well, let's see. Yes, I'm going to show you something though. The first term is 4, and then 14, and then 24, and then 34. What's your question, sir?
I was going to say the fourth term.
So I think Hayden already said it. 34. Oh, you said the third one? Okay. We already knew what the third one was. Didn't? Okay. So the question really about this is, we know that the fourth term is 34, but the question is, how many times did I have to add the number 10 to the first term to get to the fourth term? How many times, Tyler? I had to add it 3 times. We added 10 3 times to get the fourth term. So let's see. 3 is 1 less than 4. I think that might be an important idea. So it says, use what you learned in part A to find the value of a to the 10th. Well, let's see. If I want the 10th term, well, I know that if I know what the common difference is, well, first of all, if I know what my first term is, and then I add 10, how many times do I have to add it if I want the 10th term? Well, if I wanted the fourth term, I added 10 how many times? Sebastian. So you add it 9 times. So the 10th term is 94. I want to explain that because this is our explicit formula. Dang it. When I try to change the color or pull up the toolbar, it doesn't let me. It just shrinks everything. Okay.
Are you anyone special?
I'm not. I don't like this form. No, I don't need help, but thank you. Okay, so here we go. We're going to write the explicit formula. So here's how this works. Any term, any number of term depends on the first term plus the common difference multiplied by the n minus 1 term. So I'm going to use that formula and talk about a to the fifth, because we know that a to the fifth would be what? What would the fifth term in this be? Go ahead. 44. So let's use this equation and see if we can make that happen. Let's see. A to the fifth is the first term. What's the first term in my sequence? 4 plus, what is the common difference? What are we adding each time? 10. Oh, I don't know why I wrote a D there. 10 times, what is, we're looking for the fifth term. So what's 5 minus 1? 5 minus 1 is 4, right? Because this is the nth term, 5. So what is 40 plus 4? That's our fifth term. So I'm going to highlight the formula that gives you the explicit formula. That's your explicit formula. And you're going to use that today when you're doing your homework. But you still need to know how to write the recursive formula, which is question C. So question C says, what is the recursive formula? Remember, with the recursive formula, you need to know the first term. What's the first term in our sequence? 4. To find the recursive formula, I always have to take the term that came before. So how do I show the number of term, like the term number before n? N minus 1. So a to the n minus 1. And what are we doing each time to this sequence again? Adding what? 10. I heard Jane say quietly, plus 10. So this is your recursive formula. We're going to use them both, okay? Jacob, you got that? You got that written down?
Yes.
Thank you, sir. Is everybody good for me to slide up? Okay. So the seats in a small amphitheater, so this is like a small playhouse, have a pattern where each row has a set number of seats more than the last row, meaning each row is increasing by a common difference. If the first row has 6 seats, we don't know how many the second row has. We don't know how many the third row has, but I think we do know how many are in the fourth row. How many seats are in the fourth row? It says it right here. How many seats are in the fourth row? 18. We need to figure out how many seats are in the 20th row. So let's see. Here's what I know. I know that each time I'm going to add the same amount plus D. Each time I'm going to add the same amount plus D. Each time I'm going to add the same amount plus D. What am I adding? 4 each time. Good job. Each time I'm adding 4. If I add 4, 6 plus 4 means there's how many seats in the second row? 10. And if I add 4 more to that, 10 plus 4 means there's, and if I add 4 more to that, I get 18. Okay. So my common difference is 4. I need that. My first term, the first term in my sequence, or how many seats are in the first row, is what? 6. Right? I have 6 seats in the first row. So I need to figure out what the 20th term is. So I'm going to use my explicit formula. A to the n equals a to the first term plus my common difference times n minus 1. And I'm solving when n is 20. So now we're going to plug numbers in. Okay. So what is the first term, or A1? What does that equal? 6 plus. What is the common difference, or the script D? 4. Times the quantity, what is in? 20 minus 1. So let's do some math here. That says 6 plus 20 minus 1 is 19 times 4 is 76. So how many seats are in the 20th row? 82. Can you open the door? Someone is out there. Please and thank you. Yeah, hurry it up. Benaki. So I want everyone to get that little piece of paper out that I gave them. That's going to be helpful. Yep. Absolute value. Do you have something to write with? Go back there and get me a piece of paper, please, behind my desk. Do you need me to scroll down again? No, you can't. We're not done. The symbol for absolute value for these two lines. Okay. So if I said the absolute value of -5, it's 5. This symbol makes the number positive. So the absolute value of 4 is 4. The absolute value of -9 is 9. The absolute value of 10 is 10. The absolute value of -2 is 2. Okay? It's always positive. Okay? So find all numbers whose absolute value is. Shh. What did you just say? Do you need to go out in the hallway?
No.
Then you need to zip it right now. Got it?
Okay.
Shh. I mean it. Okay? Give me a second. We're almost done. Have a seat. Okay. Stop. Here we go. Are you going to be all right? Everyone's going to be fine? Okay, then shut your mouth. Let's finish this up. Tyler, do you need to go out in the hallway? Then stop. All right. So this little section of notes that I have right here is helpful for you. This is going to help you do your homework. So this formula right here is the one that we used yesterday. This is called the recursive formula. This is the recursive formula, okay? This tells us what's happening if we're given an equation and we're only given one term. Like I know what the first term is. So if I wanted to find the second term, well, that's 2 minus 1 plus 4. But what is 2 minus 1? 1 plus 4. But what is my first term? 2 plus 4. So all this is saying is add 4 to the previous term. That's what this is saying. Add 4 to the previous term. So if we know the first term is 2 and we add 4 to it, what's the next term? 2 plus 4 is? Anyone? 6. And then we add 4 to that. What's the next term? And we add 4 to that. And we add 4 to that. And we add 4 to that. 22. And we add 4 to that. 26. 1, 2, 3, 4, 5, 6, 7. So those are all of the first 7 terms. The common difference, the thing that we're adding, is right here. This tells you what you're doing to each term. This is saying take the previous term and add 4 to it. That's recursive. Okay? Flip your paper over. And so we can talk about explicit. So this is the explicit. This is the little piece of paper that I gave you, okay? This is the little piece of paper that I gave you at the beginning. So the explicit formula is what you use when you want to find like the 50th term or the 207th term. Yeah, because sometimes it doesn't make sense to just keep adding the same amount. You could do that forever, right? That's super tedious. So that's when you use the explicit formula. So to use the explicit formula, you always need to know the first term and you need to know the common difference. So what is the first term in my sequence? And what is the common difference? What am I doing each time? I'm subtracting 5. Okay. So if I want to find the 23rd term, a to the 23rd is, what's the first term again? We just wrote it. 6 plus, what's the common difference? -5 times the quantity. What number are we using for n? What's n? It's the 23rd. So 23 minus 1. So let's simplify this a little bit. That means a to the 23rd is 6 minus, because plus and negative is minus, and 23 minus 1 is 22. So minus 5 times 22. Well, 5 times 22 is, you're close. That was 11. Double that. What's 55 doubled? 110. Okay. So it's 6 minus 110. But 6 minus 110 is negative 104. So you would have had to just keep writing -5, -5, -5, -5, -5, -5, -5 over and over and over again. What if you need to find the 207th term? That would be forever, right? So this is how you find the nth term, the 20th, the 70th, the 200th. Okay? So your homework is page whatever that works.